We have till now seen the electrochemical cell or the galvanic cell. Uh, Now we are looking at the electrolytic cell. Okay, so please write it. Electrolytic cell. So what is electrolytic cell? Go from we use electrical energy in order to do some chemical reaction. So in this case, we say that we non-spontaneous redox reaction that occurs when we apply some electrical energy, and in this case, what we can say electrical energy it is converted to chemical energy. Okay. Let me just wait one more minute for Rishita. If she joins, then it's fine. Otherwise, we'll start anyhow. Please write it, please. The cell in which non-spontaneous redox reaction occurs due to which. Good evening, Rishita. How are you?
I'm good, sir. What about you?
I'm good. Due to which we have just started, so you can start writing, Rishita.
Yes, sir.
Due to which electrical energy is converted to chemical energy. Okay. Now, when this happens, obviously there will be a chemical reaction that is happening. Now, that chemical reaction is going to give you some compounds, and that is known as electrolysis. Okay. So please write the process of decomposition compounds into ions by the passing of electric current in molten or aqueous state is called electrolysis. Let me know once you're done, guys. Waiting for Rishita and Harsha. देखिए, so I'm giving you a bit of idea like what happens here, and I will write all of those points also, so you don't have to worry. In electrolytic cell, we need to give electrical energy, right? So we need to have some kind of battery which will be attached to some electrodes. Fine. No need to draw this. Here you will have cation and you will have anion. So now what will happen? As soon as we start the current, as soon as the cell starts working and the current is flowing, the negative charged ions will go to the positive part, positive electrode, and it will get neutralized. That means anion will go to the positive terminal and the cations they will move to the negative terminal. And then they will also get neutralized. So that's what happens here. Here, so simply we can write theoretically. First thing, when electrolytes are dissolved in water, or if they are in molten state, they split into ions. On passing current, ions are attracted towards oppositely charged electrodes. Next point, anions reach anode and get neutralized. That is oxidized. Cations reach cathode and get neutralized. That is reduced. Sir, how can you say that anion, when they get neutralized, that is oxidation, and when cations get neutralized, it is reduction? Suppose we have A negative, when it will become neutral, it will be A0. So obviously negative to 0, it is what? Oxidation. But if you have cation, then it will become A0, that is obviously what? It is reduction. Okay? And wherever oxidation happens, we call it anode, and wherever reduction happens, we call it cathode. Simple. Next you can write movement of cation and anion, movement of cation and anion is called electrolytic conductance, and the change is known as primary change. Last point, I hope this is quite obvious. For electrolytic cell, E will be negative and delta G will be positive, because a non-spontaneous redox reaction is occurring here. Raise your hand if you're done. I've just written the point that I have spoken about and explained, right? Raise your hand if you're done. Now, there are two segments in electrolytic cell that you have to study. One is known as the qualitative analysis that deals with the reactions, what reaction will take place when you start the cell or if you give it electricity. And what will happen to the electrolyte if you pass current on it. So it is basically what is going to be formed, like what is going to be formed when the reaction happens. So that is known as the qualitative analysis. Next, we have quantitative analysis, also known as the Faraday's law. In that, we deal with what amount of product is formed. Okay. So how much is made, that is Faraday's law, and what is made, that is it. This part that we are going to study today, qualitative analysis of electrolytes. Okay. So please write the heading, qualitative analysis of electrolytes or products of electricity. Right, the first point, like how can we decide, like what are the factors that affect the product formation in electrolysis or during electrolysis? Okay. So please write factors affecting formation of product during electrolysis. Number one is the nature of electrolyte. Nature of electrolyte. Meaning whether you are taking NaCl or you are taking CaCl2. Now, what electrolyte you are taking, according to that, the product is going to be formed. Secondly, mode of electrolyte. Mode of electrolyte. Whether you are taking molten state or you are taking aqueous state. Okay. So when you take the molten state, then in that case you will have only the electrolytes, pure electrolytes. That means, for example, if you have NaCl, then it will be Na plus and Cl negatives only. But when I take aqueous, then in that case we have water also. So we have to keep in mind that water can also be electrolyzed, right? So water can also give you some kind of product if it reacts in the cathode or the anode. Third is nature of electrode. Whether it is inert or it is active, whether it is going to take part in the reaction or not. And the fourth one is concentration of solute. Write this down, raise your hand once you're done. समझ में आ रहा है ऋषिता एंड जाइना?
Yes, sir.
जी ठीक. Waiting for Rishita. Right. Write a remark. See, if you have one cation and one anion, and you're electrolyzing the solution, it has only one cation and one anion, and or you can see if it has only two species, then the formation of product can be easily predicted. The cation, that one cation, for example, sodium positive, so sodium positive will go to, it will get reduced in the cathode and it will form sodium, right? If I have only one cation, if I have only one anion, then also that's going to be the same case. But if we have more than one cation or anion, then it's going to be a bit problematic, and we have to see there what is going to happen, what should not happen. First point is if solution has only one cation and one anion, then formation of product can be easily predicted. But if solution has more than one cation or anion, then see what will happen to the anion. If you are having two anions, then which will get oxidized? The one which has higher oxidation potential. है ना? And if you have two cations, then which will get reduced? The one which has high reduction potential. Simple. ठीक है, तो जिसका ऑक्सीडेशन पोटेंशियल ज्यादा, that will be preferred in their while the reaction happens. If the solution has more than one cation or anion, then the anion with higher oxidation potential, and also size plays a matter, and small size gets preferred at anode, and the cation with higher reduction potential and small size gets preferred at cathode. Done, everyone? Waiting for Rishita. Tell me. First cell that we are going to have, Okay, please see what I am doing here and try to ask question if you have any doubt. Okay. So first is don't write now. Try to see what I am doing, how I am doing this. Molten NaCl with platinum electrode. And we have already seen platinum electrode is an inert electrode. It is not going to take part in the chemical reaction. So when you have NaCl, as soon as you melt it, you will get Na positive plus you will get Cl negative. And there is no other chemical species in the solution. So what are the species that we are having? We have Na positive and we have Cl negative. So obviously Na positive will go to the cathode. So at cathode, what reaction will happen? At cathode, you will have Na positive eating up one electron and giving you sodium solid as the product. Okay. Similarly, at anode, chlorine negative will get neutralized and C. Sorry. Chlorine negative will not give you Cl. What is the elemental state of chlorine in the real world? It is Cl2. Chlorine exists as Cl2, so it will form Cl2 gas. Now, for this Cl2, you have to put here 2 plus 2 electrons. And now it is balanced, completely balanced. So the products that we are going to get is sodium solid at cathode and Cl2 gas at anode. ठीक है, copy this down now. समझ के आराम से. I hope you have understood this. Similarly, try to do this one. Molten CaCl2 with platinum electrode. कर लेंगे CaCl2 वाला जायना एंड रिश्ता.
Yes, sir. Yes, sir.
रिश्ता फटाफट हो जाएगा ना. Send your answers on my WhatsApp.
Yes, sir.
उड़ी बाबा, ऐसे कैसे चलेगा? जायना,
Yes,
ना,
sir.
देखिए क्या गलती की आपने, बताइए जरा।
Um,
Hmm. Can you see the problem? यस जायना, बताइए क्या गलती की आपने? जी, टेल मी।
कहाँ सर?
सॉरी व्हाट?
क्या- हम्म, कहाँ गलती की?
आप बताइए। जस्ट सी ना व्हाट आई हैव रिटन एंड व्हाट यू आर राइटिंग, you would understand it.
हम्म, uh,
Till species everything is fine. Then look at cathode what you have written, at anode what you have written, and what you are doing there, and how we have done it.
cathode. So calcium will come in cathode.
Let's see, do you have Cl2? Do you have Cl2?
Yes, a Cl2.
Like when, no, how you don't have Cl2? Now what you have? You have calcium 2 positive, and you have chloride ion. You don't have Cl2, right, Zaina? You don't have
Uh,
chlorine gas. Now, do you have chlorine gas?
no, Cl2.
No. Do you have calcium solid? Tell me. Do you have calcium or you have calcium ion? What do you
Uh,
have? Yeah.
calcium solid.
No, you don't have calcium solid. Where do you have calcium solid?
CaCl2.
When
No,
you have
those
taken
are ions.
CaCl, correct. That is true. Correct. You have CaCl2. That is calcium chloride. That is not calcium solid. Sodium chloride and sodium, they are hugely different, vastly different, right, Zaina?
Yes, sir.
Sodium chloride you can eat. Can you eat sodium?
No.
No, right? So when I say calcium chloride, it is calcium chloride.
Yes, sir.
Again, calcium chloride will be solid, but we don't have calcium, right? So how can you start with something that you don't have? For example, you started the reaction with Cl2. We don't have Cl2. What do we have? We have Ca2 positive and Cl negative. Now, cation will go to the cathode and get neutralized, and ion will go to the anode and get neutralized. Okay, please redo this. Redo this. I hope you understood that. Understood this, right? हाँ.
यस सर, सॉलिड नहीं है,
Okay.
मैंने गलत लिखा।
हाँ जी जी. हाँ रिश्ता. Done. चलिए हम स्पीशीज तक तो लिख ही सकते हैं, मतलब तो आपने सही किया सभी. अच्छा. Zana, can I have your mic on?
यस सर।
Okay. So tell me, in cathode, which species will go calcium 2 positive or Cl negative? What will go to the cathode?
कैल्शियम, सी
Hmm.
ए टू पॉजिटिव।
Calcium. Cation to cathode, है ना? Cation to cathode. ऐसे याद रखिएगा. Calcium 2 positive. So it will get neutralized. That means it is going to eat 2 electrons and become calcium solid.
यस।
And what will go to anode? Cl negative. Yes. यहाँ तो Cl negative या कोई बचा कर सकते. So Cl negative will get converted to Cl2 gas, plus it will get balance it like this 2 Cl, so it will give you 2 electrons. So the products will be calcium and chlorine gas atom. Done. आगे बढ़े. Done.
Yes, sir.
चलिए देखो, नेक्स्ट केस इज क्वाइट इंपॉर्टेंट, aqueous NaCl. ध्यान से देखिएगा, डोंट राइट एनीथिंग. Aqueous NaCl with platinum electrode. Aqueous NaCl, it is also known as brine. You must have heard this in your lower standard. ठीक है, तो brine करके भी सवाल आ जाए तो घबराइएगा. Now what are the chemical species that we are going to have? You will have Na positive as before. You will have Cl negative as before. And another thing that you are going to have, it is water. You will also have water. Now, what are the possible reactions at cathode? Okay, please see. Possible reaction at cathode. Now, obviously, in cathode, obviously, Cl negative is not going to go. Na positive will go. It will eat one electron and will give you sodium solid. Sodium solid. Okay. We know that E naught of this reaction is negative. है ना, reduction potential क्या है इसका? Negative. Because if you remember, लेके बारात काना मजे से आया, all of these are wedding elements. The wedding element, they have negative standard reduction potential. So the SRP of this reaction is negative. Next, water can also get reduced in this way. You have water, okay? So water will form hydrogen gas on reduction. ठीक है, हाइड्रोजन गैस ध्यान देखते रहिएगा है ना. So there are two things. ना H plus, there will be some H plus part and there will be some OH negative part in water. The H plus part is going to give you H2 gas. What is remaining? OH negative will be remaining. Right? So यहाँ पे अगर हम देखें, then I can write plus, after electrolysis you will get OH negative. I'm teaching you how to write the reaction, है ना, how to memorize it. H plus से तो H2 बन गया, तो बचा क्या? You should be remaining with OH negative. Fine. Okay. So we have OH negative, so that means C तो हो नहीं सकता है, तो यहाँ पे आप क्या करेंगे, 2H2O and there will be 2 OH negative which will be outside. Now if you see the atoms are balanced, now you have to balance the charge. In the right hand side we have 2 negative charge, so you will add here 2 electrons and the charges are also balanced now. Got this all of you? Yes or no? Please tell me. समझ में आई कैसे करना है इसको? ठीक है. Now, what about the E naught of this particular reaction? So this E naught is very near to zero because you're forming H2 now, and indirectly it is happening via this reaction. H plus is getting converted to H2. So the E naught of this reaction, it is not exactly zero. It is also negative, but it is very near to zero. It is minus 0.83 volts. It is approximately zero. तो कौन बड़ा है, जीरो बड़ा है या नेगेटिव बड़ा है? तो ऑब्वियसली जीरो इज ग्रेटर देन नेगेटिव. That is why this reaction occurs at what? There are two possible reactions, sodium and the reduction of sodium or the reduction of water. So what takes place? What is going to take place? See, if the solution has more than one cation or anion, then the anion with higher OP and small size get preferred at anode. The cation with higher reduction potential and small size gets preferred at. So higher reduction potential किसका है? Higher reduction potential is for water molecule. And the reduction potential is quite high. For example, लेके बारात काना अगर आप देखिए, it is quite negative. The value, exact value is minus 2.71 volts, and the exact value here is minus 0.83. So when you have a very large difference in the electrode potential or the reduction potential of the two species, then you don't look at the size. You only look at, this is the major factor. काफी difference है यहाँ पे. But the same thing if I see in anode, please see here, possible reaction at anode, then in this case, one reaction can occur is 2Cl negative is going to give you chlorine gas. Is going to give you chlorine gas plus 2 electrons. The E naught I am telling you, the E naught of this reaction, it is equal to minus 1.36 volts. Then we have the same reaction. In this case, what is going to happen? You will have water. नाउ द OH नेगेटिव पार्ट पे आपको क्या मिल जाएगा, O2 मिल जाएगा. So here you have two options. तो आपको यहाँ पर two करना ही पड़ेगा. And how much excess will be there? There will be four excess. You can see that. Now when there will be four positive, this side is neutral, the left side is neutral. So here also you have to make it neutral by adding four electrons. So this side is also net neutral. The E naught of this reaction is equal to minus 1.23. अब यहाँ पे जो है डिफरेंस बहुत ज्यादा नहीं है. So in this case size matters, the charge also matters. ठीक है. So in this case what happens when the chlorine negative is there and O2 is also there, like if you see only the E naught, then what should happen? Then in that case water should be formed. ये होना चाहिए because it is having lower oxidation state. Sorry, it is having lower electrode potential, है ना, standard reduction potential इसका कम है, तो ये जल्दी हो जाना चाहिए. This is come in the sense it is less negative, that means it is higher. एक बार फिर से हम इसको रिपीट कर देते हैं. Between chlorine negative and water, whose oxidation is more easier, Rishita and Zaina? इसका oxidation easier है according to the values of electrode potential. Whose oxidation is more easy?
H2O.
हाँ, H2 is more easy. ठीक है ना, याद रखिएगा. चलिए ठीक है, सेम समझाना चाह रहे थे. But still what happens, the chlorine reaction takes place. Why? Because of the size and also the charge. Because water, it is neutral, it takes a lot of time to reach anode and start the reaction. Due to this slowness, chlorine gets preferred. Due to this slowness, what happens? Chlorine gets preferred. And water, when it reaches the anode, it requires only this much energy. But in order to make the water reach the anode part, it requires some extra potential, and that is known as over potential. ठीक है, तो इसको हम लिखा देते हैं एक दो चीजें. The formation of O2 in anode is slow as very few water या OH negative reaches the anode. This slowness leads to the need of just give me a second guys, leads to the need of greater potential than E naught. This is called over potential or over voltage. Raise your hand once you're done. Take एक दो चीज और लिखे हैं यहाँ पे. Then we will write there for Cl negative is preferred at anode. The product you will write H2 gas at cathode Cl2 gas. And raise your hand if you're done. Waiting for Rachita. चलिए अब लिखते जाइएगा 4 aqueous AgNO3 with platinum electrode. What are the species here? We'll have Ag positive, NO3 negative, and water. So in cathode, Ag positive plus electron gives Ag. I hope you guys remember that this is a Kappa element. That means the E naught for this reaction will be positive. The other possible reaction that can happen is two water molecules plus two electron giving hydrogen gas plus two OH negative. And we have seen that the E naught of this reaction is negative. So obviously, which is greater, Ag plus is greater. So in that case, Ag is going to happen, right? Ag is going to be formed at cathode. In anode, you don't have to look at NO3 negative because it is too large. ठीक है, इसको देखने की भी जरूरत नहीं है आपको. What you will do directly, you will write 2H2O. It will give you O2 plus 4H positive and 4 electron. ठीक है, so the product is going to be Ag solid at cathode and O2 gas at anode. Raise your hand once you're done. Waiting for Rishita and Harsha. Rishita only, Harsha का तो लिखा हुआ होगा. Fifth लिखिएगा. Aqueous H2SO4 with platinum electrode. ठीक है. So in this case, species is going to be H positive, OH negative, and water. So in cathode, it is very easy because whether you take H positive, then also you are going to get H2. You can balance it like this. Or if you take water, then also you are going to get hydrogen gas. Okay, so no matter what reaction is going to happen, you are always going to get hydrogen gas in the cathode. There is no competition here. There is no other product that is possible. At anode, however, there are two different cases. If you take dilute H2SO4, then in that case, water will be present in more amount, and then this reaction will occur. Water getting converted to O2 plus 4 electron plus 4H positive. This reaction will take place. But if you have concentrated H2SO4, then in that case, SO4 2 negative ion, it is going to take part in the oxidation and it will form S2O8 2 negative plus it will give out 2 electrons. And this can further form H2S2O8, which is known as peroxodisulfuric acid. Peroxodisulfuric acid. One question that can be asked in this case is that in the oxidation of SO4 2 negative, which atom is getting oxidized? So in this case, oxygen is getting oxidized. Okay. So all the four oxygen in this SO4 2 negative, it is having -2 oxidation state. But in S2O8 or peroxodisulfuric acid, the bonding is like this. And you will have one 2OH, there will be one double bond O. Okay. So this is the structure. So this oxygen is having -1, this oxygen is also having -1 because it is having what peroxo linkage, na? So because of sulfur and oxygen, this one is going to have -1, this oxygen is going to have -1 because of this bond. But because the oxygen is having a bond with oxygen, both these oxygen will have -1 charge only, not -2. ठीक है. So oxidation किसका हो रहा है इसमें सल्फर का? No, it's not happening for sulfur. Sulfur is in +6 state in the SO4 2 negative as well as in the peroxo disulfuric acid also it is in +6 state also. ठीक है. So please write here in oxidation of SO4 2 negative, oxygen atom is oxidized. So you can write product. Number one, if you have dilute H2SO4, then in the cathode you will get H2 and in the anode you will get O. But if you have concentrated H2SO4, you will get H2 in the cathode and you will get peroxodisulfate or peroxodisulfuric acid. Copy this down, raise your hand once you're done.
Sir, can you show the cathode part?
Raise your hand if you're done. Just waiting for Rishita. Last two that we have here is, right, the sixth one, aqueous AgNO3 with silver electrode. Okay, so please see what happens here. Don't write anything now. ठीक है, देखिए. Here we have Ag positive and NO3 negative. ये आपके पास पॉजिटिव टर्मिनल है, दिस इज योर नेगेटिव टर्मिनल, है ना. बट the Ag itself, what we are having here, Ag, silver. So silver itself, it is reactive. And what will happen when you add a metal in the solution of its own salt? The metal from electrode इस तरह का एक equilibrium आ जाता है. Metal gets converted to M positive and M positive. It reacts with lithium. This type of equilibrium it gets established, and that is why there is a potential difference which gets there. So when you are going to put Ag electrode in AgNO3 solution, then what is going to happen? Ag is going to get converted to Ag positive, and this same Ag positive is going to go to the cathode and get nucleated. तो जो यहाँ पे रिएक्शन होगी ना, बहुत ही आसान है इसमें. Ag का ही ऑक्सीडेशन और Ag का ही रिडक्शन. ठीक है. What will happen in cathode? कैथोड या पहले एनोड देखे थे. In anode, Ag from the rod, from the electrode is going to get converted to Ag positive, plus it will give you one electron. In the cathode, the Ag positive from the solution will get converted to Ag by the addition of one electron. Like this. So, this is very useful for the purification of Ag. So, I'm writing here this electrode in green, showing that this is impure. This is impure Ag, impure silver. This is pure silver. So what will happen from impure silver? Only the silver, not anything else. If you have, let's suppose, copper inside it, or if you have any dust particle, or if you have any carbon particle, or if you have any dirt in it, then the dirts are not going to get converted to Ag positive. Only the Ag in that impure rod is going to get converted to Ag positive, and that Ag positive is then directly getting converted to Ag. So this is used for purification. Used for purification of silver. And how the purification will take place slowly? The mass of anode will decrease, and mass of cathode would increase with time, है ना? Copy this down, raise your hand once you're done. Waiting for Rishita. A very similar one is, please write next with me. Aqueous CuSO4